questions from last time? Excuse me, I still got a voice problem. Are there any other questions from the assignment I gave you in class?
Could we do number 27?
Sure, 27?
Yep.
I got a question sheet.
So the figures below show all the diagonals that can be drawn. So once again, just like in class, I made a chart. In one column, keep track of how many sides, and then in the other column, and this is the new, keep track of how many diagonals. Now, what's a diagonal? A diagonal is anything that connects, but that is not on the side. You know what I mean? It cuts through the center. So the first figure has 4 sides, and it only has 1 diagonal. Second figure has 5 sides on the outside and only has 2 diagonals, and so forth. 6 sides, 3 diagonals. Okay, so can you tell a pattern? I mean, all you have to do is look right here. Is there a pattern here? Sure, it just goes up by 1 each time. Yeah. So now this, I mean, here I actually came up with a formula, but that's not necessary. All that's really necessary is that you discover the pattern somehow. So you could say, as I add a side, I wind up adding 1 more diagonal, something like that.
Is it okay that I just drew it out instead of doing the algebraic equation version?
Yeah, I mean on number 9?
Oh, number 27.
Oh, 27?
Yeah.
I just did it. You don't need this.
Okay.
All you had to say was, looking at the chart up here, as I add 1 more side, the number of diagonals simply goes up by 1. If you would have said that, I would have seen that you discovered the pattern. And then it says, can you tell me how many diagonals can be drawn for vertex that has 10 sides? Well, we're up to 7. Sure, you could just go what, 3 more? And what's 3 more than 4? Did you follow that? I mean, if you're at 7, if you go to 10, isn't that 8, 9, 10? That's 3 steps. So this is going to be 5, 6, 7. So that would have been the non-algebra way to solve that one. I think that was Elliot that asked that. Elliot, does that make any sense?
Yeah, I was just saying, like, based on, like, on number 27, they actually drew out
Right.
shapes. And oddly enough, I mean, not oddly enough, I should say, I got the wrong answer. I got 9. So I just did it wrong.
Yeah.
That's cool.
So I turned it into a numbers problem.
Right, which I should have did, but I didn't.
Well, that's okay. Sometimes you can just do it graphically, like that kind of a weird clock problem we did in class last time. That one we actually did by leaving it as like a picture. So sometimes you know it can go either way. Any others from last time? Okay, we better get started on the new lesson. So in your notebooks, well, yeah, just by the way, this is just a review slide from last time, which shows, I just wanted to show you that this pattern solving really is a big deal here. This is a little bit old, but you can see they actually have discovered one of the main ways they find terrorists is they actually do find the patterns. So we talked about law enforcement. Okay, let's get started on the second lesson. So, remember last time we started chapter 2? You guys remember that? We said chapter 2 is called sets.
Yep.
And then our lesson was 1.1. Well, here's our next lesson, 2.1. So now we're really in the physical chapter 2 in the book. So in your notebooks, you want to put the title up there, 2.1 Sets, a problem-solving tool. And the pictures here are just my way of illustrating. We use sets quite a bit, don't we? We got a set of golf clubs, set of dishes, a chess set, a set of tickets, a set of tools. So we use sets all the time. Now, so we got a bunch of terms today, guys. All right. So first of all, what is a set? So we still have a lot of noise out there. I don't know if anybody can maybe mute their mic. Might solve a few problems. I don't know. Some of you still probably haven't found that, but yeah. Wow, we got a lot of noise. Normally we don't. Hope you can still get something out of this. So anyway, what's a set? Well, I mean, in my own words, it's just a group of things, a group of objects. And it could be a set of problems. It could be a set of dishes, any one of those. One thing about sets is we never list multiples. So, for example, when I was a kid, I was a big baseball card collector. The Milwaukee Braves, I know it goes back to the 1880s again, but when the Milwaukee Braves were in town, I really wanted a full set of the Braves baseball cards. And, I mean, when you had a collection, you didn't display that you had 5 of one guy. You only displayed 1 of each. You would keep the doubles in the back for trading. Likewise here, when you list a set, we never list multiples more than once. Elements are not repeated. There are 3 ways to define a set. One way is just write them all out. So here you see set A defined as the numbers 1, 2, 3. Keep the pattern going until you get to 10. You guys remember this ... thing? We talked about it last time. ... means continue the pattern. How many numbers do you need to establish a pattern?
3.
Yep, at least 3. So if I would have put 1, 2, ... that would not have been good. So we're good. So this is the numbers 1 through 10. This is a set listing. Another way you're going to think is kind of corny is just using words. So here's another way to say it. All counting numbers from 1 through 10. Okay. And the third one you might have a little trouble adjusting to. That's called set builder notation. Set builder notation, you're going to see, is necessary. There are some things that can only define this way. So let me read to you what this says. Actually, I have a translation down below. All x, such that x is a counting number and x is between 1 and 10. So that x/x stands for what I've written right here. All x such that x, and then as it continues here, is a counting number. You're going to see that there are some sets that can only be described this way. So if you're wondering, why am I giving you all 3? We need them all. So part of the assignment is going to be to use all 3 kinds sets. Just write them all out and make a listing, or just write them out in words, or, and you'll see we're gonna, for some things we have to use set builder notation. By the way, the reason you need set builder notation is sometimes, otherwise you would never be done because they're infinite. So here's an example of a set builder notation. Okay, well, first look at the top. Way up at the top of the page, you should see the set of natural numbers. You know, 1, 2, 3, ... Okay, isn't that just all natural numbers? Okay, we're okay. We can write that all out. We don't have a problem because the ... covers us. But what happens when you get down to fractions, rational numbers? Okay, what are all the fractions? Well, 1 over 1, 1 over 2, 1 over 3, 1 over 4, ... But that's just the ones with 1 on the top. What about the ones with 2 on the top? You just don't have enough, you don't have enough tools to say it. And so look what we have right here. You need set builder notation. So that's just an example of sometimes you have no choice but to use set builder notation. So one more time, let me go back. Tell you what that x/x means again. x/x stands for all x such that x. And then you describe it in various ways. I just need to introduce that to you. We'll get to that as we move on. Okay, then a very special set. You're going to think this is stupid, but it's the empty set. The empty set is a set with nothing in it, absolutely nothing. And it turns out it's pretty important. Sometimes we use this symbol. And sometimes, you probably have noticed, when we draw sets, we put these funny looking brackets, and then we put the elements in between. Well, what if you put nothing in there? That's the empty set. Okay? Next, equal sets. Equal sets are just what they sound like. They're sets that have the same contents. And do you notice? Here I have two sets A and B. They are equal. Notice that the elements that are in the sets don't have to be in the same order. We don't really care what order the numbers are in. So sets A and B are equal. Okay, so that's pretty easy. That's an easy concept, that one. Any questions on those two before I go to the next one? All right, let's go. Now, if you're an outliner, you know what a subheading is, right? It's something that's underneath and indented. Well, what's a subset? A subset is what? Part of a set. So if this is set A, the numbers 1 through 10, and this is set B, which just has 2 and 7 in it, is B a subset of A? Yes, because all of the things in B are already in A. So we would say this right here on the left. That horseshoe aiming to the right stands for is a subset of. I'm pretty sure I have that right here. Yeah. Okay. So this reads in the red circle, B is a subset of A. Why? Because all of the things in B are also in A. But D is not a subset of A. Why not? Because there's no 0 in it. Everybody sees that, hopefully. So here's the symbol for D is not a subset of A. D subset with a slash through it. Okay. I'll explain this one on the bottom on the next page. Questions on this page? Okay, let's keep going. Now make sure you put this down in your notes. This is very important. The empty set, a set with nothing in it, is a subset of every set, even itself. So this is one you definitely want to have in your notebooks. By the way, I never did say hi to Lottie or to Russ. Good to have you guys aboard.
Hi.
Sorry about the delay in the beginning. I had a few little technical issues, but we got over them.
No problem.
So does everybody have this one down? The empty set is a subset of every set, even itself?
Yep.
Okay. Now, watch out for this one. This is different from what the book says. When you have this subset symbol, this big old horseshoe aiming to the right, and when it has a bar underneath it, then it stands for is an improper subset of. And I'll explain what that means. Okay, the idea of a subset. Sub means what? Smaller than, subset. So when you have an improper subset, it's not smaller than itself. Like, for example, here I wrote down A is an improper subset of itself. Why is it not a subset? Why is it not proper? Because how can A have less elements than itself? So I like to think of it this way. It's like the bottom of an equal sign. And the only time we use it is when the two sets are equal. So you see that? Almost like a subset equal. And that makes it a little easier to remember. The book has that backwards. They call the naked one an improper subset, and they call this one the proper. That's exactly backwards. Book is pretty good, but that is simply not correct. So make sure you note. An improper subset has that equal bar on the bottom. A regular subset, like we had on the previous page, like back here, that does not have that equal bar on the bottom. So a regular subset, just that horseshoe aiming to the right. Okay. By the way, I know these are new rules, but they're not too complicated. So if you just get a few of these facts down, you shouldn't have too much trouble adapting to this. Okay, what else do we have on this page? Okay, just a comment. You will see a script U. I'm not real good at my handwriting, but that's a capital U in writing there. That is often used in the book to stand for the universal set. I'll show you an example right now of using that. So, well, maybe not. I'm getting there. But first of all, here's a set I made up. Set A. Okay, and let's just say it's got the numbers 1, 2, 3, and 4 in it. Okay, we have this new symbol. This funny looking E stands for is an element of. And so it's proper to say 1 is an element of set A. Why? Because it's right in there. It's in set A. 2 is an element of set A, etc. But 5 is not an element of set A. Okay. As a little review here, I have a new set down here, a set with just the elements 1 and 2 in it. Is that a subset of set A? So is this true? Is that a subset? Let me get rid of this. Is the set with 1 and 2 in it a subset of A? It is. Yes, because all elements 1 and 2 are also in set A. Good. Okay. Okay. Now, How many subsets does a set have? There's actually, guess what? A pattern. So we're going to go back to our good old pattern recognition from last time, and we're going to review that a little bit. So I made up, here's my first set right over here. Let me get a different color so I can highlight this in blue. Here's my first set. I'm just calling it A1. It only has one element, 1. What are its subsets? Well, it could be, this is what? The improper subset. Why is it improper? Because it's got everything in it. Is that really a subset? Yeah, it's an improper one. And then, remember the empty set is a subset of every set. So set A1 has 2 subsets. So when A has 1 element, it had 2 subsets. So I'm going to start writing this down. We're going to see if we can find a pattern. Okay. All right, now here's my second example. Set A2. And this time, it has 2 elements, A and B. What are its subsets? Well, it's some obvious ones. A, B, and even this, the improper subset's okay. Everything, A, B, and then there's that weird guy, the empty set. So when I started off with 2 elements, how many subsets did I have? 4. Okay, we're going to try finding a pattern over here, all right? I haven't gone far enough yet. Let's go the next route. Let's take a look at the third set. Here's the third set. It's got 3 elements, circle, triangle, square. Circle, triangle, square. How many elements? 3. Now, subsets. Well, we got the singles, the set with just circle, the set with just triangle, the set with just square. And then we got the so-called duals, 2 at a time. Circle, triangle, circle, square, triangle, square. And then there's the improper subset that's got everything in it. And then there's the empty subset, the empty one. How many subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. Do you see a pattern over here? Does anybody see a pattern? When I had 1 element, I had 2 subsets. When I had 2, I had 4. When I had 3, I had 8. Any pattern over here?
The previous number times 2?
Exactly. So what you're saying is the next one should be what?
16.
That's correct. Well, here's the easy way to remember that. If I just grab this and move it away. Well, it's up here on the top. If n is the number of elements, then 2 to the n power is the answer. So in other words, this is 2 to the 1 power. 2 to the 2 power is 4. 2 to the 3 power is 8. 2 to the 4 power is 16. So what if there were 8 elements? Then it would be 2 to the 8th power. 2 times 2, 8 times. So this formula right up here, guys, in the box, you need to remember that. How many subsets does a set have? 2 to the n power, where n stands for how many elements it has. Okay, and one of those, of course, is the improper subset. So sometimes they'll say, let me add a slide. Sometimes you will also see, you'll see this in the book too, where it'll say this. Number of proper subsets is 2 to the nth power minus 1. Why? Because there's always one improper subset. So if we just went back here, you know, take a look at these sets I have for set A3 down here. Okay? Remember these guys down here. Okay, what if I take out the improper one? Well, that's that one. Oh, I've got one less. So this also makes sense. But, I mean, you don't really have to memorize that. If you learn the one on the top here, the number of subsets is 2 to the n power, then the number of proper subsets is always just one less. Okay. So let's take a look at a problem in the book. So if you got your books handy, open up to page 67, please. I'm sorry. I gave you the wrong page. The page is not, it's number 67, and it's on page 62. Sorry. Page 62, number 67. It says in 67, if A is the set of numbers divisible by 2, what are the numbers divisible by 2? Any even number. So I wrote it out. 0, 2, 4, keep going like that forever. And it says B is the number of elements divisible, number of the numbers that are divisible by 4. So now it's 0, 4, 8, going on forever. And here's the first question. Look up here. Is A a subset of B? I know I have the answer down there, but do you see that it's no? Why is A not a subset of B?
Because it doesn't follow the same pattern as A, like the
That's
so A is like all even numbers
yep.
in that pattern, and B is all numbers divisible by 4.
Can you give me one? Can you give me one number from set A that's not in set B?
2.
2.
That's correct. That's all you need. Yep. Excellent. How about the other way around? Is B a subset of A?
Yes.
Yes, because all those numbers 0, 4, and 8 are, you can't see it, but 8's going to be up there too, right? Because if you keep that going, it's going to be one of the evens. So, okay, well, there's a problem. Let's also, we've already talked about that.
Could you do me a favor and go back to that one more time, please?
You bet.
Okay, I just wanted to make sure I write down that.
Yeah, I'm sorry, I moved off of it really quickly.
So shouldn't okay, never mind. I just answered my own question. Never mind. We're good.
Well, I'm glad you asked me to come back. Thank you for calling me.
No problem.
Okay, I just have one more I want to talk about, guys. And that is, if you look at page 62, the same page again, look at number 71.
Record.
Have you guys, do we still have Baskin Robbins ice cream in Milwaukee?
In Tulsa.
Okay, and what do they advertise? How many flavors?
31, right?
That's right. Now I'm gonna talk about that a little bit. How many flavors do they need to make 31? Now let me give you an example. Here's what I mean by that. Let's just say we have vanilla and chocolate and strawberry. Okay, just for a moment. Vanilla, chocolate, strawberry. How many flavors can I now publish? Well, we've got 3, but couldn't I do a vanilla chocolate combination? I know it doesn't sound good. Or couldn't I do a vanilla strawberry combination? And couldn't I do a chocolate strawberry combination? So actually, what do I have here? 1, 2, 3, 4, 5, 6. I can actually advertise that I have 6 flavors when I have 3. In fact, here's how it works. It's actually, we just had on the previous page, it's 2 to the n. But there's one set, somebody could say, well, I want all 3. Okay, somebody's got kid videos playing in the background. Interesting. But anyway, it sounds like a fun video, but that's not me cheering
Yeah,
over here.
I just walked past with her tablet.
Okay, well,
2 people came in late. Maybe you could reiterate how to mute the sound.
we'll try this the 4th time. You guys that came in, some of you may have to mute your microphone. If you go to the top of the page with your mouse, you should see a little black menu come down, and it's got a microphone on it with a slash and a camera with a slash. And if you hit the microphone with a slash, it'll mute your microphone, and then we won't get all this feedback. Anyway, I'll try to show you next time. So in the last page, you remember this? You guys remember this formula? That was how many subsets there were? If a set has n elements, well, guess what? It works with this ice cream in this way. If you have, like up here, I have n equals 3. I have 3 flavors, vanilla, chocolate, strawberry. N equals 3. How many subsets are there? What's 2 to the 3rd power? It's 8. Now, let me explain. What are the 8? Well, here's 1, 2, 3, 4, 5, 6. And then there's what? Vanilla, chocolate, strawberry, 7. And then the last one is the empty set. And of course, no idiot is going to go up to the counter and say, I'll take a cone with no ice cream. But if they did, that would be the equivalent of getting an empty set. I mean, nobody's going to go buy just a cone and pay the ice cream price. But you see how this works? In other words, in number 71, they talk about hamburgers. The same deal. They say, all right, we got these toppings. Ketchup, C, mustard, M, O, onions, P, pepperoni. Wow, pepperoni. I'm sorry, this I went to the wrong one. Never mind. Anyway, you could make them up. Onions, ketchup, pickles, make up your own cucumbers, I don't get, whatever. And you could make up, how many toppings would you need to have 256 hamburgers? Well, you'd need 2 to some power, 2 to some n to equal 256. Let's just do it together. If you do it twice, what's 2 times 2? That's 4. If you double it again, now we're on 3. Now you're at 8, right? 4 doubled is 8. If you double it again, 4, now we're on 16. 5, if you double it again, now you're on 32. 6, double it again, you're at 64. 7, double it again, you're at 128. And 8, if you double it one more time, you get 256. Well, if you just had 8 condiments, you could put up a big sign and say, we offer 256 kinds of hamburgers. And the guy that says, I want the works, well, he's going to get a lot of stuff. And the guy who says, I want the empty set is just going to get, a plain hamburger. So anyway, Baskin-Robbins, the only reason that it's not, if you do 2 to the 4th power, you get 32. Why did they say 31? Because nobody wants the empty set. So anyway, you'll see. I think 71 is going to be one of your, I think that's going to be one of your problems. Let's get, so let me just repeat. What is this right here? This is an important formula for today. It's the number of subsets that a set has when it has n elements. By the way, we finally solved our muting problem. Thank you to all of you. Sorry, with no instruction, you guys have done a good job today. I apologize. Kind of threw you into this. But now we actually have no feedback. Cool.
Would you be able to move the page up a little because the vision is under pictures?
I have the pictures turned off. Okay. Yeah, how about, let's see, does this help?
Yep, that's great. Thank you.
Okay, thank you for asking. Sorry. Yeah, I thought I turned the pictures off and they are on mine, but evidently, okay, you might have to do that individually. Yeah, thank you for asking that. So, what did we have for our lesson? Some new terms, a bunch of terms, and we're gonna. It's really not that complicated. We've got these sets, these groups of things. We learned about subsets. We learned about sets that are empty. We learned about sets that are equal. And we learned that a set that's equal is a special kind of subset called an improper one. And basically, the assignment is just to get you a little more used to that. So let me go to that now. So, see if all of you understand this. Here's what I have for the second assignment. Okay. Once again, when I say assignment, what does the book call it? They call it exercises. So you see how it's right here. This 2.1. This is what the book calls it officially. 2.1 exercises, and you'll find that on page 60. I want you to do the odd numbered problems from 1 to 71. And then I'm just throwing in a couple evens, 10, 12, and 14. See, because you already have, so 1 to 71, these are pretty quick problems. The odd numbered ones, by the way, that's what you'll find in the back of the book in the answers, the odd numbered problems, so you can go check them. And then I just have you do 3 evens, 10, 12, and 14. Questions?
This is due on Wednesday?
Yeah, this is, so now with the one lesson we had on Wednesday, added to this one, there are 2 assignments that are due for Wednesday. That's correct. So we just split it up a little bit. That's the idea of this online class, so we don't have to jam this all in one night. Questions?
I have a question for number 25. I
Okay.
think it's number 25.
25 on what? On the one that was on 1.1?
Yeah.
The assignment that was from last time?
Yes.
Okay, 25. So here's what it is. Get back there. By the way, we did that at the beginning, but I know some of you were a little late and it was our first night, but that's fine. Okay, number 25. Let's take a look. So they have this little drawing in the book that I tried to duplicate. I didn't draw the bars, but so what I did then is, do you see how they have those numbers at the bottom? 1, 5,
Yeah.
12. So I took those numbers and I used our method of differences. Do you remember that from last time? 5 minus 1 is 4. 12 minus 5 is 7. 22 minus 12 is 10. 35 minus, that method of differences. And now the question is, do you see a pattern here? Do you see a pattern on those numbers on the bottom?
Yeah, 3.
Yeah, 3. I was gonna.
Yeah, exactly. So the next one is? What comes after 13 then on that line?
16.
Yep, and 16 plus 35 is 51, and then 19, etc. So that one I think could have been turned into a number problem. I don't know if you saw the numbers down there, but that would have been the way I would have. Is that enough to suggest how to keep going on that one?
Yeah,
Okay,
thank you.
you're welcome. Yeah, any other questions? I know some of you got in here a little later, and this is our first time, and I realize that. Anybody still want to bring up questions from last time?
I have a question regarding expectations. Like, I see some of the problems have been solved pictorially or numerically, or
Yes.
as long as we show the work, how we got it, would you want to?
I would be happy if that's what you did, yes. And you are right. There are, some of them can be done kind of graphically, some of them numerically. Either one is fine with me. So yes, if you just kind of leave your traces on the paper so I can see what you did, I'd be pretty happy with that. Good question. Anyone else, questions? Otherwise, I was getting ready to wrap it up for tonight. And you now have 2 assignments for our next class on Wednesday. But we still have time. Any other questions somebody would like to raise? Well, thanks for jumping in tonight. I know I kind of just threw you in the pool here, but I think you can see now that we maybe got a little bit of a hang for the volume controls and things. This can be hopefully this can be a good tool. It has in the past, and hopefully we can use it again. Thanks for joining me tonight, everybody.
Thank you.
See you on Wednesday.
All right.
Good night.
Bye.
Good night.
Good night.